let's look at bytes, and also we'll look at nibbles. So a byte is 8 bits, and you can have big endian and low endian depending on your CPU architecture. So basically, it depends whether it interprets from the start or the finish, I believe. So when you work in, you might see 2BE. BE means big endian. If you see LE, it doesn't mean less than equal or less than equal to. It actually means little endian. So when we're working with bytes, we have the option to have an array and then modify part of the array. So if we've got a byte, which is 8 bits, we can modify a particular part of it. I'm still learning this. I've come from a Python background, really, a Python and a network engineering background. So both slightly overlap with bytes, but really Rust is where I'm really going to start getting my hands dirty with this. So um, the other thing I've looked at is nibbles, and that's even more interesting because what you can do is you can define two pieces of information and then you can pack them into a single byte. So typically a single byte would be representing one thing, but to save space, especially with networking and obviously with like packets and things that you're going to be sending many times, you could put the version. So for instance, the version of IP, the IP version, so version 4, version 6, etc. You could put that in the left-hand part of the 8 bits, and you can put the header length in the kind of the right-hand 4 bits. Let me just run this. It couldn't compile because reason. I think it didn't like the comments. Let me give those. There we go. So version 4 says IP4. The header length is 5 bytes, which is uh, packet packed byte. So that's the bit that represents the 4. So it's no ones, no twos, and 1 4. So that there is representing the 4. And obviously the 101, reading it from right to left, is 1 1, no twos, and 1 4. So that's what's giving you the 5 here. So in Rust, and also the size of the packed byte is 1 byte, 1 bytes. You can do that by using standard mem size of val. So I just wanted to start looking into this, and I've started using bytes with the network side of things. So the multi-threaded web server, which takes bytes, and conversion between bytes. So you can convert between bytes and a string, or string to bytes, and so on. One other useful or interesting application is with it's amazing how compact you can do. You can make things once you start dealing with bytes exclusively. For instance, a Bitcoin transaction, for instance, immense amount of information just with a very few bytes, and that is also um, it's using hex as well, which means you can fit more information with less characters. So here we're doing the OR. So the OR is that's the version 4, which is the left-hand part of the byte. Um, and it's got those 4 zeros, which are kind of packing it out. And then down here, so what happened was we shifted 4 places as we look at it. We shifted the number 4, we shifted it 4 places to the left. And then we've got our 101, which is number 5, but it's wasting all these zeros on the left-hand side. If you OR those 2 numbers together, then you end up with this. And then obviously when you not deconstruct it, or when you unpack it, which is what we did at the end, we've got the version and we've got the header length, because the packed byte represents version and the header length. So version, comma, header length. That's all because we were able to extract the version and the header length because we packed it into a single byte called packed byte. And it's 1 byte. So I'm still learning this, but I just thought it'd be useful just to kind of briefly cover it. And yeah, I'm sure there's way better tutorials than this on what I've just talked about, but this is me learning it, so it's quite a nice intro level, and it does relate very much to networking, TCP, and so on. Yeah, so in future videos, I'll probably relate it more to something a bit more real world. But yeah, just also bear in mind the little endian and the big endian, and remember that you can modify a single byte by indexing it. And yeah, feel free to screenshot that, copy it, do whatever. So thanks for watching. Thumbs up as usual, the comments, like, and all that. Thanks. Cheers.